Okay, so this is number one off of the 612 test. So what do? Do I have any exponents on the outside? Parentheses. No, so what am I saying?
Mary, or no, numbers.
Numbers with numbers, letters with letters. Okay, now this means I have how many little problems up here? I have 3 problems, right? So if I have 5 to the negative 3, how is that different than negative 25? Negative 25 says that I owe somebody $25, correct? I'm in debt. Y'all with me? 5 to the negative 3 is not being in debt. It is a fraction. That's like saying I ate 5 to the negative 3 parts of my pizza. I ate a fraction of my pizza. Do we all understand that? Why am I saying that? Because I have to put this over 1. And if it was a negative exponent at the top, where does it go? To the bottom. The negative 25 says it's a negative number. The 5 to the negative 3 goes to the bottom to make the exponent positive. Are we all good with that? Now, a to the negative 2 times a to the first. Why is there not a 1 there? It's understood to be there. So what do I do with those exponents? Do I add, subtract, or multiply? I add them. Just add the exponents, Shayla. Okay, what do I do with the exponents on the b?
Yeah.
You add them because they're attached by multiplication. How do I rewrite the number 25? 5 squared. So what I have going on here is negative 1 times 5 squared over 5 cubed. A to the negative 1, b to the negative 5. Right? The negative 1 is there because it's a negative. 25 is 5 squared. So how many 5s do I have on top? 2 5s. How many 5s do I have at the bottom? So what happens? How about those 5s are gone up there, and this 5 cubed turns into just a 5? Do we all understand that? I have 2 up on top, I have 3 on the bottom. 2 up and cancel out on each top and the bottom. I'm left with 1 on the bottom still. Negative 1/5. What happens to the a to the negative 1? It goes to the bottom. And the b to the negative 5? To the bottom. There's my answer. How many of you got that correct whenever you redid it? Good. How many of you got it correct whenever you were doing it with me right now? Because you were all supposed to be redoing them to practice. Are we good on this one? You feeling it? It was actually really good. I heard you have so much, and I'm very happy about that. Wait, what happened? Number 2.
Don't you distribute negative 4 to 3?
You are going to multiply those exponents because I have a power to a power. When I have a power to a power, that means I multiply my exponents. So that's going to be u to the negative 24, u to the positive 24. Now, how are those two u's attached? So how do I get rid of them? No. Well, add, subtract, and multiply. Add them because it's 2 of the same bases attached by multiplication. So I add my exponents. So that's negative 24 plus 24. 2 bases attached by multiplication means I add my exponents. To give you, what's negative 24 plus 24?
0.
Do not leave it as 0 there. What do I write? 1. Anything to the 0 power, it's always and forever 1. I guarantee I won't get you.
Mark, that's wrong.
Yes, because it is wrong. We're going to skip 3 for now because we already did that previously. We're going to do number 4. Write it down and get busy on it.
That's feeling like I'm right.
I want you to redo them because practice makes perfect, and I guarantee you did that with somebody else, which means can you reproduce it by yourself without somebody else's help? Know what I'm saying?
Actually, I think so.
Huh?
I said actually.
You think so?
Right.
Good. I want you to do it.
I don't know.
I want everybody to reproduce it all by the lonesome here. What's the first step you think you should do?
Distribute that 5.
Distribute that 5 to what?
The 3.
To the 2, to the R, and to the S. Do we all see that? But exponent on the 2 is a 1. So I'm going to multiply those exponents. That gives me 2 to the 5th, R to the 15th, S to the negative 15th. All over 4, R to the negative 7, S to the negative 10. Am I saying numbers with numbers, letters with letters? Well, I have this 2 to the 5th. What in the sandhill is that?
32.
It is 32. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is set at 2. What do I do with my R's? They're attached by division, so what do? I just subtract. So that's going to be 15 minus negative 7. S to the negative 15 minus negative 10. Set that chair down before you fall and have to do paper. That takes me off. And then I have to ask if you're okay. I should have that. What's 32 divided by 4?
8.
8.
8. Minus a negative is? To give me R to the minus a negative? Positive S to the negative 5, y'all. Negative 5. Y'all. Put this thing over 1. Now what?
Put the S and negative 50 in the bottom.
8, R to the 22nd stays, S to the 5th goes to the bottom. How many people got that?
I understand what we're doing. Right here.
Good, good, good.
Yes.
Number 5.
Let's do that.
Oh, thanks. Yep, this, I understand this.
Yeah, I can't remember.
Yep, that's
Okay.
where you are.
You can seriously type this in your calculator and get the answer without any problems. But I have never taught it to you like that. Stop it. The way I have taught this to you is by using the place value system. So look. You okay? Tens, hundreds, thousands, 10,000. So what place value is the one in? 10,000. So what I have going on here is 81 over 10,000. The fourth root of the top over the fourth root of the bottom. Yes?
I was starting it off right.
Oh.
I just did that last week. I wasn't sure.
So now, what number multiplied by itself 4 times is 81?
3.
3. What number multiplied by itself 4 times is 10,000? 10, to give you 3 tenths. I would accept either answer.
Wait, that's 3.
3 over 10. Yeah, it's not that difficult. And how many of you did this crap on your paper? Don't do that. Okay, don't do this because 3 tenths is always going to be 3 tenths. It's always going to be positive because it's saying I have 3 tenths of, let's say, $1 million because I don't. Okay? It says I have money. It's positive. I can see it. It's never going to be negative. So therefore, is this ever going to be an issue? No, you don't need to take the absolute value of a positive number. It's always going to be positive. Okay? Moving right along, number 6. This one y'all checked up. I don't know why, I just did. I have 2 of these lovely little radicals attached by multiplication. Are my indexes the same?
Yes.
So what do you think I can do? Marry them. So I'm going to marry this whole thing. The square root of 3 over 28 times 175 over 3. What are your instincts telling you to do? Please do it. Do you know how many papers I saw where you guys just said, oh, there's a 3 at the top and a 3 at the bottom. What should I do?
I didn't do that.
You just totally ignored it and you left it there. I don't want you to do that. I want you to acknowledge that there's the top and the bottom has something in common. Now, if I have $1.75 in my hand, how many quarters do I have?
5.
7.
7.
That was hard work. Wow. So this is going to be 7 times 25 all over what? Well, how do I rewrite 28? 7 times 4. What happens to my 7s? My 7s go bye-bye. So what I got going on here is the square root of 25 and the square root of 4, which is 5 over 2. Right?
You just made it look so much.
Logic skills. Yes. Can I plug all that into the calculator? Sure, you can. Well, the calculator going to give you 2.5? Yeah. Why is it giving you 2.5?
Because that's the reduced.
Because that is the decimal of my improper fraction of 5 over 2. Are we good?
Yay.
Am I going to like if you give me that fraction or that decimal without any work?
Now because
I'm going to be like, minus 2.
right into the calculator.
You okay with that?
Yeah.
You okay?
Yeah.
You sure?
Yeah.
Okay.
Hurts.
What?
It's my ear hurts.
Your ear
I
hurts?
see that. It's all.
You know what?
Oh, it's from Saturday, and there's
What?
there's a little kid hit me in the ear. Got kind of
I would have beat that little kid.
Okay, number 7. Okay. 7. Talk to me. Is 81 a perfect fourth?
Yeah.
Yeah.
Yes, perfect. Okay, what about this? Is 15 divisible by 4?
No.
No, so I need a number lower than 15 divisible by 4. 12. So this is going to be the fourth root of 81, m to the 12 times what?
Where?
M cubed. Why m cubed?
What?
Because I have to have a total of 15 m's inside there. 15 is not divisible by 4, but the first number that's smaller than 15 that is 12. And then I still require 3 more m's to give me a total of 15.
Okay, so you still are gonna have 15 inches.
Yes, I still have 15. I'm just writing it so that I can get rid of some of my m's. Is 10 divisible by 4?
Yeah.
No. Would I get a number smaller than 10 divisible by 4? So what's going to give me? N to the 8 times n squared.
I got that.
Are we all good on that? Do we all understand where all those numbers came from?
Yep.
Now, what is the fourth root of 81?
Great.
What is the fourth root of m to the 12? What is the fourth root of m cubed? It's k. What is the fourth root of n to the 8? And what is the fourth root of n squared? Can't. So I have going on out here is going to be 3m cubed n squared, fourth root of m cubed n squared.
That's where I get that.
Am I done?
No.
Why? Around what?
Um,
Why only around the m do I put absolute value bars? Okay, first of all, I have a possible absolute value because my index is even. Then I'm going to look at my reduced powers, and I take only the odd ones, and I put the absolute value bars around them. Because the n squared, if I square a number, whether it's positive or negative, the outcome will always be positive. So therefore, I don't need to worry about what n is, because my outcome will always be a positive value. Are we good on that? Correction.
I
Shayla?
understand why you have the fourth root or whatever and this third.
Because that's what's still left over inside. The 3 is smaller than the 4, the 2 is smaller than the 4, so therefore they stay underneath the radical.
Why did I get this one wrong?
Ugh.
I got happy with my pen. I'm sorry. It didn't kind of Okay, number 9. Number 9, talk to me. I apologize.
Number 8.
Did I skip 8?
Yeah.
No. Did I?
Yeah, you did.
Yeah, you did. Number 8. What else did I skip?
She knows she skipped 3. We did
I
that
skipped 3
already.
on purpose. We've done that already. Number 8. My apologies.
Yeah, Mary.
Why should I marry them?
Doesn't have like
Because their indexes are the same. So I'm going to marry the junk on the outside, and I'm going to marry the junk on the inside. So what's 7 times 2?
14.
So I have 14 times the square root of. Can you tell me 2 numbers multiplied together to be 42? Because see, I don't want to get a really big number, do I? So I'm going to use my brain. I'm going to break down 42. 6 and 7 sounds great to me. How about 56? Can I break that down into 2 numbers?
Yeah.
8 and 7. Sounds great to me. And then how many total x's do I have in there?
7.
7. How many total y's?
6.
Okay, perfect. Now this 7 times 7 tells me that I have what going on? 2 7s in there to give me 49. What is 6 times 8?
48.
It is 48. Now, funny story about 48. It has a perfect square factor in it, doesn't it? What is its perfect square factor? The highest perfect square factor. 2 is not a perfect square. Who said 16? 16 is a perfect square. So what you're telling me is this is going to be 49, which is a perfect square, times 16 times what? 16 times what is 48? 3. Can I break down 7? It's not divisible by 2, but what should I rewrite it as?
Six.
Good. How about y to the 6? It just hangs out. Okay, are we ready?
Hold on now.
Whoa.
49 is.
Why did you?
Why did we go to X?
Because
Yeah.
7 divisible by 2. We need a number smaller than 7 divisible by 2.
Oh. So wait, you multiplied it by X.
We did look at it.
Gotcha.
Square root of 49.
7,
Square root of 16.
4,
Square root of 3. 6. Square root of x is 6.
X cubed.
Square root of x. Square root of y to the 6. Okay, so what I have going on here, what is 14 times 7 times 4?
392.
392.
What?
X cubed, y cubed, square root of 3x. Yes? Am I done?
No.
Why?
Absolute value just around there.
It is an even index, and my powers that I have reduced are what? They're odd, so therefore I need to tack on those absolute value around both of them. And now I am done. Do we understand that problem?
Somewhat.
I broke it down like farther than what you did, like as in inside the. But I
Okay,
still got the same answer.
I'm sorry.
I still got the same answer.
I don't care how you did it as long as you got it right. If you can justify your work to me and show me, I'm good to go with that. If you can't justify your work, then I am not good to go. More than one way to kill a deer. As long as it's dead and you can justify how you did it, I'm good to go.
Like when Mr. Miller was helping me, like his made sense and yours is.
I'm okay with that. I'm okay with that. Whenever I teach, I purposely don't teach using a calculator. Because how many people grab a calculator all the time? I want you to use your brain. Nine. What do I do with this thing? I want to see it.
Number, letter for letter. What?
Wow.
Wow.
You broke down this and then had to marry those. Totally legit.
Yeah.
Okay. These right now are divorced, aren't they? Let's marry them back together. Why do I want to marry them back together? Because 96 is divisible by 3. And my indexes are the same, and I have like terms underneath the radicals. So what's 96 divided by 3? What is x to the 9 divided by x squared? I have 9 up top, 2 at the bottom. Those 2 got to go away, and 2 got to go at the top. So what am I left with? X to the 7.
Wait a
9 minus 2.
Oh. Wait a minute, so you just divided, okay, I got
I
that.
subtracted.
Yeah, that was really easy.
We're not done.
Oh,
Is 32 a perfect fifth?
Yes.
Yes.
No.
2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Is 7 divisible by 5? Let's see.
No.
Yeah.
No. So I need a number smaller than 7 divisible by 5. What is that?
Ah.
That's the fifth root of 32, x to the fifth times x squared. Good job, Casey.
What's
What is the fifth root of 32? What is the fifth root of x to the fifth? And what do I do with the fifth root of x squared? Keep it. So this is going to give me 2x times the fifth root of x squared. Am I done?
Yeah.
Why?
Because that's an odd index, and that means.
When your index is odd, there is no absolute value required. When your index is odd, there are no absolute values required.
Hold on, let me try. All right, I got it.
Okay, moving on. Number 10. These 2 are currently what?
Divorce.
Divorced. Would it help us to marry them to see if anything cancels out from the top and the bottom?
Yeah.
Does anything cancel out if I marry them?
Yeah.
Well, my exes cancel out. That's one less thing I got to worry about, right? So this x is gone and that x is gone. I have how many y's up top? 2. And how many do I have at the bottom? 3. So that means all of those y's are gone up top, and I'm left with 1 y at the bottom. Do we all understand that? So what's going to be my fraction? The square root of 3 over the square root of 5y. you see what I have going on up there? Does it make sense?
We're going.
So I simplified them and then I divorced them. Wasn't that nice of me?
Terrible job.
Okay, so now what do I do?
Multiply by 5y.
Why am I multiplying by the square root of 5y?
Because you need five.
Because I need to rationalize that denominator. What that means is I have to get rid of that radical in the denominator. I have the index being a 2, correct? So that means I have to have 2 of every single term underneath that radical to put 1 on the outside. I currently have 1 5 and 1 y. So I need to tack on another one so that I have how many total down there now? 2. So I marry those. 5 times 3 gives me 15y. The bottom's going to give me 5y squared. Why? Because I have 2 of them. What happens to my power, my root, my denominator? They cancel out. And I have the square root of 15y all over 5y. Do you see what I got going on up there? Can you do it by yourself? You better be willing to work your tush off tonight. 11. 11.
I don't know how to do it.
What am I doing now?
I have no clue.
Multiplying by multiplying the 3y get a cube.
Well, first of all, it's one fraction. So what should I do?
9y squared.
I need to divorce them first.
Divorce.
I don't believe in divorce, but just saying in mathematics we sometimes have. Now, I need to multiply by what? I have how many 3y's down there? 1. How many more do I need?
2.
I need 2 more 3y's. So I'm going to multiply by the 3y squared over the cube root of 3y squared. Do we all see that? Yes or not?
About it.
Hey.
What is 3y squared?
9y.
It's 9y squared. So I'm going to marry these to give me 9x squared y squared over the cube root of 3y cubed. Correct? Because I have how many of them down there now? 3 of them. And what happens to your power and root? They cancel to give me the cube root of 9x squared y squared all over 3y.
Can't you cancel out the y?
No, because the y represents the radical at the top, at the bottom there is no radical. Not the same patterns. Not the same index. Are we good on that? Yes? 12, last one on that test. Right now, they are divorced. If I were to marry the radicals, is it going to help me? Why? Because nothing cancels if you marry them. Did we all see that? Which means now I ask, does anything cancel out on the outside of the radical? 6 over 5. Does anything cancel out? No. So now I have to make this thing look pretty. It's already simplified, so how do I make it look pretty? I have to rationalize the bottom, which means I got to get rid of the radical. In order for me to do that, how many 3's do I currently have in this? 1. How many more do I need? 1 more. So I'm going to multiply by the square root of 3 over the square root of 3. So let's marry the top radicals, and what's that give me? 6 square root of 6x over 5 square roots of 9. 3 times 3 is 9, correct? What is the square root of 9? 3. So I have 6 square roots of 6x all over 5 times 3. What happens with your 6 and your 3? We got a little canceling going on, right? This 6 becomes a 2, and this 3 becomes a 1 to give me 2 square roots of 6x all over 5. Are we good? Now, guys, I've done everything I possibly could do to make this last test for you over this material better for you, right? I have given you extra time in the weekend. I've let you correct. I've let you ask questions. I've done every problem for you to make sure that you understood your errors. You don't do well on this tomorrow, who are you going to blame? Don't be coming to me crying, whining, and moaning, and complaining, because it ain't going to work. Okay? Now, section 6.4. Are there questions over section 6.4 worksheet 2? Anybody? All the answers are up here on the dry erase board. Any questions that you have for me to go over? It's the same jump. You have to remember when to add, subtract, and multiply exponents. When do I add exponents? When When their bases are attached by multiplication. When do I subtract the exponents? When the bases are attached by division. When do I multiply the exponents?
Whenever you're just multiplying and get back.
When I have a power raised to another power. Do we understand that? What's anything to the 0 power?
0, 1.
1. 0 or 1? Which one is it?
1.
1. Are we all good with that?
But I do have a question about that.
Which problem would you like me to do?
None of them.
None of them?
The 13 is 8, and the 8th root is 0. Is that 0 or 1?
8 is 0. 0 times what gives me 0?
0.
0, so it's 0. 0 was not a power in that problem. Okay, are we good? Yeah.
I was actually gonna build it down and basketball.
No.
Where do you
Test
want me to
tomorrow.
put this?
Hey,
You
it's a
have-
test, it's a test.